Welcome back again, solving few important numericals for NEET 2021 and also thereafter. The problems will be based on pulley systems, different kind of pulleys, fixed pulleys, movable pulleys. Hope by now you have watched my previous video where I explained this one, a single fixed pulley. And around it a rope goes, one mass on one side and on the other side there is another mass M2, and by using the free body diagram equations for 1 and 2, the acceleration was found out, the tension was found out by putting the value of A, and the shortcut was also explained. Now here in this one I'll explain why the tension is away from the mass, right? Then I'll come back here to solve this problem. Look at, this is a bundle of rope. I have taken a part of it. Now the question is, if I try to push the gentleman in Mr. Albert Einstein with this rope, can I push him? No, I cannot push him. But if this rope can be tied, can be fixed at some point on his body, I can pull him to this side. Of course, I will not pull him. So the tension is always away from the body to which it is attached, right? I cannot push him with the string, with the rope, because it is a flexible one. It is not solid like a steel, right? Now look at the problem. Normally in a NEET examination, which is a competitive examination for admission to different medical colleges in India, including AIMS, normally they don't ask questions where the mass of the pulley is to be considered and the mass of the string is to be considered. It is never asked like this. So now let me straightway go back to the problem. This part, you can imagine, this part is a table. At one edge there is a pulley fixed here to the table, and it is a fixed pulley, and this mass, let it be M1, and this mass, let it be M2. Now of course this mass is not fitted with an engine or a motor so that it can move automatically to this side or this side. It is just a inanimate mass, right? And so what will happen, this mass M2, due to its weight M2 times G, due to the pull of the earth, this mass will be pulled towards the right. And this string is massless. The mass of the pulley is also neglected. So as I just explained you, why the tension is always away from the body to which it is connected. So here for M2, the tension will be to this side, and it is the same string. Not a stretchable string. So here the tension for this mass will be away from it, the same tension T, because it is the same string. Now if you consider the tension for this pulley, it will be away from the pulley, and if you consider this tension for this pulley, it will be away from the pulley, right? But we are not interested to find the motion of the pulley about this axis. We are only interested to find the motion of this mass and the motion of this mass, find out the tension and acceleration. Since the length of the string from this point to this point passing over the pulley is fixed, so on this side, if the string drops down by a length equal to x, and on this side the same length will move to this side, because the length of the string is fixed, and it will happen simultaneously, right? The time during which this mass falls at distance x, in the same time this mass will move by the same distance x. Means what will be, the velocity of this to this side will be equal to the velocity of this to this side, and the acceleration of this to this side, if it is a, the m1 will also have the same acceleration to this side. Now let me take okay, I have already taken this as m2. Normally I take the masses on the right as the m1, so let me take it as m1, sorry, let me take it as m1. So this is m1g. Let me take this as m2, right? So that's all. And now if you look at m1, that is being pulled down due to its weight m1g, and the tension is trying to oppose that motion. This t and this m1g, they are opposite to each other, and since this is falling down, so m1g has to be more than the value of t. So for this m1, the net force is m1g minus t is the net force on this downward. So that will be its mass into acceleration, m1 times a. Now if you look here, there is no force to this side, and there is no friction here also. So it is only tension T that is moving this mass m2 towards right. So on the mass m2, the net force is the tension. So T will be equal to its mass m2 times acceleration, right? Now there are two equations, two variables. If you add the left hand side of this with the left hand side of this, right of this with right of this, t cancels. On this side you are left with, by taking a common, m1 plus m2 times a. On this side you have m1 times g. So your acceleration will be, this comes to the left hand side, so it is divided, m1 plus m2 times g. It is wise to write the expressions in a decent way. I have kept the masses in bracket and acceleration due to gravity next to that. Kilogram plus kilogram is kilogram. Kilogram over kilogram, kg cancels. So this is just a number. Number into acceleration is acceleration, and this is your acceleration. Now I'll come back to the shortcut. Shortcut also very quickly. Now if you put the value of this acceleration here, you will also find t. And if you put it here, you will also find t. But by putting it here, you will find it quickly here. So tension will be, I'm writing it here. So tension will be m2 times this acceleration. So I can write it here. That is equal to m1 over m1 plus m2 times g. Now to make it look little better, I take m2 inside. So m1 m2 over m1 plus m2 times g is your tension. So since it is a fixed pulley, the acceleration of this and the acceleration of this m1 will be equal, and that will be equal to m1 over m1 plus m2 times g. Now how to do it quickly in less than a minute, right? How to do it quickly in less than a minute. So let us imagine this mass m1 on which this force m1g is acting vertically downward due to the pull of the earth. Let us imagine this mass to be horizontal like this, and the same force, this mass, I now tilt it like this, make it horizontal. So this is your m1g, and this part of the string where the tension, this is the string, so this is the tension. I don't have to consider this because this is an internal force, and since there is no force here to this side, so if you consider this as a system with this as m1 and this as m2, then net force is m1g and the total mass is m1 plus m2. So your acceleration is equal to net force by total mass. So that is net force is equal to m1g over total mass is m1 plus m2, and you can rewrite it as m1 over m1 plus m2 times g. That is the same thing as we derived it here by solving these two equations. So that is the fastest way. Now the teacher might play a trick while asking the questions. He might say, instead of saying the mass is m1, the mass is m2, he might say the weight of this object is w1. Means w1 will be equal to m1g, and the weight of this object is w2. So w2 will be equal to m2g. So you can rewrite these equations, the expression for acceleration and the expression for tension, in terms of w by substituting from here m1 is equal to w1 by g, and from here m2 is equal to wt over g, right? Try it yourself. Means this expression can be expressed, and this acceleration expression can be expressed in terms of w instead of m1 and m2, right? So you have to be careful that way. Similarly, let me show you the previous video. Here the teacher, the examiner will be asking the question. He might also play a trick. He might say the weight of m1, this is the first video, this I had explained in my video lecture 1. He might say the weight of m1 is w1, means you have to write w1 is equal to m1 times g. Similarly, w2 will be equal to m2 times g. So from here, if you take m1, your m1 becomes w1 over g, and similarly from here your m2 becomes w2 over g, right? If you substitute the value of m1 and m2 here, this was explained in the previous video. I forgot to explain these two terms. So here in this case, your acceleration had come out to be m1 minus m2 over m1 plus m2 times g, and your t had come out to be 2m1 m2 over m1 plus m2 times g. If you substitute m1 is equal to w1 over g and m2 is equal to w2 over g, where w1 is the weight of m1, w2 is the weight of m2, then just substitute. Then this expression in terms of w will look similar, means A will come out to be w1 minus w2 by w1 plus w2 times g. But if you substitute here for m1 and m2 w1 by g, and for m2 w2 by g, in this expression the g term will not come. You can try. So this will just come out to be 2w1 w2 by w1 plus w2. There will be no g term here, right? So that you have to be careful. This I had explained in the first video, and this I just explained in the present video. And I just explained why the tension has to be away from the mass to which it is connected. By writing the equations you can solve, but to do it faster, you imagine this m1 to be horizontal and this m1g is acting horizontally to this side. So on the system, net force is only m1g on this whole system. The string does not have any mass. So So since this is internal, I neglect it. So acceleration is equal to net force over total mass, that is m1g over m1 plus m2. Take g here. This looks beautiful. So that is how you can find out quickly in less than 1 minute if you are a NEET aspirant, because the questions are asked in such a way that the time duration available with you is just only 1 minute. So you must learn certain tricks. Okay, I'll be uploading few more videos on pulleys that can help you solve your numerical problems in NEET 21 quickly. Thank you.